Good day everyone, and welcome to the GTAC Tech Talk webinar on Access Control Configuration Part 2, Access Issues and Wiring Basics. Thank you for attending today. My name is Derek Schaefer. I'm a Technical Training e-Content Specialist with Genetec, and I'll be your host for the webinar today. And we also have some members of the Genetec Technical Assistance Center standing by who will assist with the webinar questions and answers. Our first GTAC expert is Roger Neptune, who is one of our technical support engineers with the Access Control team. And we also have Scott McFall with us today to help with questions as well. Scott is an e-content specialist with the GTAC. If you have any questions during the webinar, you can just type them in the question box in the GoToWebinar console, and one of us will get back to you with an answer as soon as possible. Now, in case we need to verify any information for your question, we'll make a note of it and get back to you via email as soon as we have an answer for you. All the questions and answers from the webinar will be posted on the GTAC Tech Talk section of the Genetec Technical Assistance Portal forums about a day or two after the webinar has finished. If you have any additional questions or comments on the webinar or the GTAC Tech Talk webinar series in general, you can post them in this section of the GTAP forum as well. Now, all the videos from the previous webinars can be found by going to the Tools section and then go to Videos and click on GTAC Tech Talk on the left. Now, there's two ways that you can watch these videos. The first one here is by streaming in a browser window, and you just click on the clipboard icon right here. Or you can download a zipped Windows media file by clicking on the second icon right here. Now, if you'd like to receive emails concerning the latest additions to the Genetec Technical Assistance Portal, you can log into the GTAP, go to the My Account section, go under Email and Notifications, and change the Notifications section below. You can check the boxes of the subjects you're interested in and select how often you'd like to receive an email when there have been additions to those sections. To put a checkbox next to a subject, the frequency here will have to be set to daily or weekly, otherwise the options below will be grayed out. You can also edit your subscription to our two Genetec newsletters in the section above it here, and don't forget to hit the Submit button on the bottom to save your changes. Now, before we get started, I'd just like to take a brief minute to take a look at the agenda for the webinar today. We're going to start out with a very short introduction, taking a look at the goals for today's webinar and where we might see the various problems that we're going to be talking about. From there, we'll start talking about the common issues and how to troubleshoot them, starting with problems adding units, going to the issues which may cause a unit to drop offline, then what to do when the doors are not unlocking, or when credentials are not working. And our last section is on problems with unit synchronization for the troubleshooting section. And then, of course, we have our wiring basics section will be the last part of the webinar. So let's start out by taking a look at the goals of today's webinar and basically what we're trying to accomplish. So the primary purpose of the webinar is to address some common access control problems people have encountered when working on the Security Center system. Now, there is some overlap between the different problems, but we'll try to cover it in a way that you can go back and reference it easily later on. Now, when looking at an access control system, there's more than just the software side of things, of course. We have to take a look at the hardware as well. With that in mind, we're going to take a look at the basics of access control wiring and the hardware involved in an access control system. Now, we could fill a day talking about that subject in general, so I'm going to cover most of the topics that may be unfamiliar for anyone new to the access control world. Now, in the previous webinar, we mentioned we'd be taking a look at the global cardholder configuration setup in this webinar, but we realize this is a topic that would most likely benefit from more time that we can give it with what we have to cover today. Be assured that it is on our future topic list and will be covered at a later date. Now, when considering the hardware, we're going to take a general look at the HID units that we currently have in the field, and we'll be looking at the new Synergist Master Controller, or SMC, in a webinar of its own. We'll take a look at the new HID Evo hardware in that webinar as well. Alright, before we go too much into troubleshooting, let's take a look at the topics we'll cover and which parts of the system might be causing the issue. Now, I'd just like to take a minute to discuss the connections here. The physical access control units, like the HID Edge device here, communicate with a server which is running an access manager role. This access manager role has units which are associated with the physical device, and the various readers, inputs, and outputs are assigned to door entity components. Credentials are presented to the door reader, which in turn unlocks the physical locking device if they are valid and the person may be allowed to pass through the door. Now, we can have trouble spots at several places along the line. The first problem you might see is actually adding the unit to the access manager. This could be a problem with the unit, with the connection between the server and the unit, a problem on the access manager side, or with the unit entity details. The second issue is where the units are dropping offline. This is commonly something on the unit or the connection to the server, but could possibly be a problem related to the access manager as well. Now, when the door is not unlocking when it should be, we'll need to take a look at the lock itself and the wiring, and the unit to make sure the output is configured properly, as well as take a look at the schedule that we have set up on the system. Now, when credentials aren't working, the first place to look is the credential and cardholder information, including the schedules and access rules that are set up. We also need to check the reader to make sure it's receiving the correct information and that it has synchronized with the server so it knows who to let pass. If the unit is not synchronizing, take a look at the wiring between the unit and the server and the configuration of the unit itself. So our first troubleshooting topic is taking a look at what you can do when you run into problems adding access control units to Security Center. For the access manager to be able to add a unit, it needs to be able to connect to it properly. From the main server running the access manager, make sure you can connect via the 4 main connection methods. Whenever you're trying to log into an HID unit, always use root as your username, and typically the password will be pass. Now, we've seen cases where the factory default password has changed to BTFSPLK. So if root and pass aren't working for you, give root and BTFSPLK a try. The admin user that is set up on the units shouldn't be used to try to add a unit to the system and only has limited rights on the controller. So the first thing you want to try to do is ping the unit. It should be on the same network as the server or at least accessible through a NAT. You can try to ping the server from the unit, which we'll cover in the third step here. To be able to add a unit, you'll also need to be able to view the HID configuration web page from a web browser such as Internet Explorer. The third connection test is to be able to telnet to the unit, which is commonly done through a command prompt. You'll need to make sure telnet is enabled on the version of Windows that you're running as well. The last connection test is to FTP to the unit, similar to the way we telnetted to the unit, and just do a quick fileless command to make sure the connection is active. Okay, we'll cover the other connection tests in detail in a few minutes, so we're going to start with the ping test. Now, it's pretty simple. You just need to run a command, get the command prompt up in Windows, so it's either in the pop-up menu, or you just need to run cmd from Windows, and then type ping and the IP address of the unit. It will try to ping the unit 4 times by default, and it will give you a response time if it can reach the unit. If you have a high response time or cannot reach the unit at all, take a look at the unit to make sure it has power and that the network cables are connected properly. As we mentioned, we need to be able to access the HID configuration web page on the unit. You just need to open up a web browser, and in the area where you type in a URL, put the IP address of the unit. It should ask you for the credentials to log in, and from there you'll see the basic setup screen like here. The third connection test involves telnetting to the unit. So just like we did for the ping test, open a command prompt in Windows, and then type in telnet followed by the IP address of the unit. It will ask you for the unit credentials, so just use the root and pass or BTF SPLK as we did for the web page. And once we've confirmed that we can log in, you can try to ping the server from the unit. It's basically the same command, ping followed by an IP address as when we ping the unit from the server, but make sure you're using the IP address of the server that is running the access manager this time. The response time that you get from this ping test should be less than 50 milliseconds. So once that's finished, you can type exit and hit enter, and that should quit the telnet session. The last connection test to try is to try to FTP to the unit. So from our command prompt in Windows, type in FTP followed by the IP address of the unit. And once again, it will ask for the credentials to log into the unit. And once we're in, we want to run a quick test to make sure we can transfer information. Type the ls command and hit enter. This will give you a list of the folders in the root directory. Once you're done, you can exit it from there. Now, if you can successfully connect to the unit using all four of those methods, well, that's fantastic, and we know the problem is not related to the physical connection to the unit. If we can't connect with one of the four connection methods, we have a few things to verify. As we mentioned in the ping test, make sure the unit is powered up and ready, and the network cabling is functional and in good condition. We also need to verify that the unit is on the same LAN as the server, and can be reached through a NAT if it's on a WAN on the other side of a firewall, for instance. Now, speaking of firewalls, there may be one or more set up on the system, and this might be blocking the ports we need to communicate through. So check your firewall ports and on the server and any other firewalls on the network, and make sure that 4070 and 4050 are unblocked. Now, if you want to test if the ports are open, you can stop the access manager, run netstat -NA from a command prompt, and make sure no connections are listening or connected on these ports. Now, just please note that when you do stop the access manager, your doors will go red and the other units will be running in offline mode until you restart the access manager. There's a few other ports we need to make sure are open and unblocked as well. The first one is port 23 for telnet communication, and then ports 20 and 21 for passive FTP communication. And finally, ports 1024 and higher for active FTP communication. The HID units come with a Vertex Discovery GUI, which can be used to check the network settings on the unit. If it does not have one already, give the unit a static IP address and try to add it again. Now, the last step here is to make sure the Security Center system is not installed on a Windows cluster. If the only connection method that isn't working is the web page, we can try to reboot the unit. So to do this, just telnet into the unit like we did in step 3, type the word reboot and hit enter. The unit will restart and come back up in a few minutes. If we still can't add the unit in Security Center, we're going to need to verify the settings on the access control unit. We can do this by logging into the unit's web page. And the first section we want to go to is the Advanced Network Setup. From there, we need to check the host name, which is the name we give the controller to identify itself. Now, this name must be 15 characters or less and have no spaces or special characters. As well, we need to check the domain name server set up on the unit next, and we can do this from the Advanced or Basic Network Setup. Now, if you don't have a domain name server set up on the network, make sure the primary and secondary DNS servers configured on the unit have the same IP address as the unit itself. If you've added your V1000 controller but are having trouble getting it to recognize the interface boards, go to the System Status section of the web interface. Next to the top, near the top of the screen here, we have an Add Unconfigured button, and that should search for any unit, search the unit for any missing interface panels. Now, one other thing that may cause problems when adding a unit are unacknowledged alarms on the controller. If you take a look in the System Status section, you may see that there's some red icons in there, particularly the tamper, door forced alarm, and door held alarm icons. Now there's a button next to the door in the alarm state. You just need to click on it until all the alarms have been cleared. If the unit has been set up for a while, there may be quite a few loaded up in there, and really there isn't any other way to clear them, unfortunately. However, we do have a way to keep these alarms from coming back. So in the registry, we can add a couple of keys to automatically acknowledge the door forced and door held alarms. Now from the server, open the registry editor, which you can do by running regedit. And the path you'll need to follow is this one right here. It's HKey local machine, software, Genetec, Synergist 3.0, and Vertex. If you're running a 64-bit operating system, you'll need to add WoW 6432 node after the software folder right here. Now as well, you may not see the Synergist 3.0 and the Vertex folders. You may have to just create those yourself if you need to. Now in the Vertex folder, we'll need to create two D-word registry keys. We're going to call them Silence Door Forced Buzzer and Silence Door Held Buzzer, and we're going to set the value for both of those D-words to 1. Once that's done, you need to restart the Access Manager role and clear any new door held or door forced alarms on the controller's web page. We're also going to need to check the firmware version on the unit from its web page to make sure it's one of the supported versions by Security Center. Here's a list of currently supported firmware for Security Center 5.1 SR3. Now, please note that if you're using a V1000 or V2000 controller for an elevator, you shouldn't use any firmware version higher than 2.2.7.49.1. This one right here. Now there may be a performance problem that's restricting us from adding a V1000 controller or new interface boards, so we need to make sure we're not overloading the controller. Take a look at the number of expansion boards that you have connected to each bus on the V1000 controller. We shouldn't be exceeding 10 per bus on each side. Note that as well we need to count the RS485 port 1 and 2 together as bus 1, and RS485 port 3 and 4 together as bus 2. Here's bus 1 on this side here, and these two are bus 2 taken together. Now, although a V1000 controller can theoretically go up to 32 interface boards, or 16 per bus, for best overall system performance we highly recommend keeping the number of interface boards to 20, or 10 per side. Now if you hit a situation where it starts to add the unit and the completion percentage starts to climb, but then it stops and won't add the unit, this may not be an actual problem. So typically at a certain point, usually when the percentage is in the 60s, the Access Manager is waiting for a response from the unit. The unit is busy working at that moment and it doesn't get back to the Access Manager in time, and we get a timeout problem. Now the good thing here is that the unit is still working in the background, so all we need to do is add the unit again, and when it gets to the same percentage point, the unit will have finished what it was doing and the addition process will keep going. Now if it is still stopping, however, there is something we can do for a V1000. It's possible that we may just need to update the EEPROM on the interface boards, such as the V100s, 200s, and 300s. To do this update, log into the unit's web page, go to the Supplemental Configuration section, and click on the last icon here next to the V1000. On the Security Center side of things, if this is the first access control unit you're adding to the system, you'll want to verify that the HID Vertex extension has been added to the Access Manager. Now to do that, open a System task, go to the Roles section, and click on the Access Manager role. From the Extensions tab, just take a look below and check if there's one called HID Vertex on the list, like we have here. If it's not there, just click on the green plus sign on the bottom to add an extension, and choose it from the list that pops up here. Also in the Access Manager, under the Resources tab, make sure we have the correct network cards selected. You can do this by first clicking on the Advanced View icon on the bottom right of the server list. This is what it'll look like when it's collapsed, and you won't be seeing your network card. When you do have the Advanced View expanded, you'll actually be able to select your network card from here. Now if you're using a Network Address Translation or NAT, you'll need to specify different parameters when you're adding the access control unit. In the Unit Information section of the unit creation, click on the More button just below the password here, and put in the IP address that has been assigned to the unit on the other side of the firewall. This will tell the Access Manager where to look for the unit outside of its own network. Now the next step is to make sure that only one Access Manager is trying to control the unit. You can log into the unit and verify that the IP address under the basic central station host communication setup is the one of the server running the Access Manager. We can actually test this by trying the following steps here. First, we need to stop the Access Manager role. Now remember, this will make all the access control units go offline until it's restarted. After that, we want to open a command prompt, telnet to the unit, and use the root and pass or BTF SPLK credentials as we had done before. Type in the command netstat -NA and hit enter. And take a look at the connections that are listed there, and make sure there are no established connections on port 4050. If there are, there may be another Access Manager running which is trying to access the unit, causing conflicts. You can reactivate the Access Manager role when you're finished, and that should bring all the units back up online. And this also serves as a restart of the Access Manager role, which might be necessary as well. Okay, our next common issue is where we've been able to add the unit, and it might have been running fine for a while, but is now dropping offline randomly. Now you'll notice this in the security desk as the associated doors will show up in red. In general, this issue may be caused by a physical connection problem to the access control unit, a problem with the unit itself, either hardware or software, or a communication problem between the unit and the server. Now there's a lot of different troubleshooting steps to do here, but they're all very similar to the ones that we just went through when we're adding the units. So basically the ones that we want to confirm is that we've checked the 4 major connection methods. We've checked the primary and secondary DNS servers on the unit. We need to make sure that only one Access Manager is connecting to the unit. Check the host name on the unit, make sure it's less than 15 characters. With no spaces or specials. We need to clear any active alarms, and as well check the network ports as well. Make sure that everything's unblocked on the firewalls. Now one particularly useful bit of information concerning units dropping offline specifically is that the video on the network may be causing the issue. Now, if there's too much broadcast or unhandled multicast video traffic getting to the access control unit, it may consider this as a threat and shut down the network connection. Typically, it would do this if we saw more than 5 broadcast or unhandled multicast packets within 5 milliseconds. Now, HID addressed this in more recent firmware versions, starting in firmware 2.2.7.49, and the units are now less sensitive to this problem. If you're also using the network for video, take a look at the firmware version on the access control unit that's dropping offline and see if it needs an upgrade. Alright, so our next common issue is where the doors are not unlocking even though they should be. So basically, we present a valid credential, access is granted, and the door should unlock, but it's not. We'll also consider what happens when a door is on an unlock schedule but won't unlock. Now the first thing to test is to make sure the lock is working. We can go to the unit's web page and try to activate the strike by clicking on the 1 next to the lock icon. If the wiring is fine and there are no hardware problems with the controller or the lock, it should unlock the door or at least click. If that works, what you want to do is try to explicitly unlock the door and manually override the door for about 5 minutes in the security desk to see if it unlocks. You may need to set it for longer than 5 minutes for larger sites or if you have a slower network connection. Now this way we can see if the commands are getting through from Security Center. We can also test the strike relay on the unit. Put a voltage meter on the wires going to the lock. Put a voltage meter on the wires that are going to the lock from the unit itself, such as we have in the diagram here. And then present a valid card to the reader and see if there's a voltage change when the access is granted. If the voltage doesn't change, we may have a problem with the output on the access control unit. If the voltage does change, it might be a wiring issue with the door lock itself, such as the power or relay connection, or a physical problem with the lock itself. They are physical devices, and of course they do wear out over time. Now, if a door should unlock on an unlock schedule, but the door remains locked during that time, or it randomly locks up on you, there's a few things you can check here as well. Now the first thing to check is the firmware. There's a known issue for this firmware with version 2.2.7.49, so it would be recommended to upgrade to version 2.2.7.49.1 as soon as possible. And this is, of course, just for the V1000 controllers. Next, take a look at the unlock schedules for the door to make sure it really is within the scheduled range. Now note we also have exceptions to the unlock schedules, which will keep the door locked. So take a look at the list on the right for the exceptions and look at the schedules listed there for the dates and times. Next we can go to the access control task and take a look at the unit to make sure it's been synchronizing and is up to date with any changes to the unlock schedules. You can try a manual synchronization by hitting the Synchronize Now button right here. Now, it's possible there's a problem with the schedule that's been stored on the unit as well. What you can do in that case is create a new schedule with the same dates and times and replace the current schedule on the unit. You'll need to perform a manual sync to get the information to pass over quickly. In case it's a physical problem with the hardware, go back to the web page of the unit and try to activate the strike relay as we had previously done. Also, we can give the manual unlock and override a try from the security desk to see if the problem is the information being sent from Security Center. Now, one last thing to try is to actually remove the unlock schedule completely and wait a few minutes, then try to present your card to unlock the door. Once it's off the unlock schedule, it should be responding to the established access rules it has in there. If the door unlocks, we know the unlock schedule is the culprit. Now let's have a look at the flip side of this, where the door should be locked, but the lock just unlocks on its own without having any credentials presented. As we've previously seen, check the unlock schedules for the door and the unlock exceptions. Delete and recreate the unlock schedules and assign new ones to the door to test this out. Now don't forget to manually synchronize the unit after doing this to make sure that the updated schedules are pushed over to the unit. Now if you do have a REX or request to exit device connected, check if the REX is constantly active. In the security desk, make sure you have the door listed in the Entities tab, and that way you'll be able to see the events coming in for that unit. Taking a look at the events pane, you may see that you're getting a lot of request to exit events. Now, if you are, reset the unit and check the REX for a wiring short, for instance. Now another thing we can try is to explicitly lock the door, as in the previous step, but remember we want to lock the door instead of unlock it. This way we can see if the commands are getting through from Security Center. We're going to see more about this in the wiring section, but another possible cause is the power supply for the lock. If the lock is configured for failsafe mode and the power to the lock is failing, the door will unlock. Failsafe basically means the door will unlock if there's no power going to the lock. Take a look at the power supply and the wiring to the unit to make sure there's no faults there. Related to the door lock, we might also see a case where the door unlocks, but it locks back up right away. There's a few things that we can check in this case. The door monitor input is set to normally closed, not supervised by default, even if the door contact is not being used. By default, as soon as the door unlocks, it will check to see if the door monitor is open. When it is, it will relock the door. If the unit is not connected to anything, it will look like it's open, and will lock the door before we had a chance to even open it. So there's basically two ways of fixing this. So we can either change the door monitor input to normally open, not supervised. We change that right here. Or we can actually physically short the input terminals on the access control unit itself, effectively closing the connection indefinitely. If you are using a door monitor, you'll need to make sure the contact type and supervision has been set according to the type of hardware that you're using. It's possible to have an input that opens the connection when the two sides of the door monitor device are next to each other. In that case, the input would be normally open. We'll look at supervision and end-of-line resistors in the wiring section coming up. If you're using a magnetic lock that has a built-in door contact, this may not be terribly accurate. If you're having problems, install a separate door contact and only configure that one in Security Center. In some cases, you may need to keep the lock open for the entire time that the door is open, such as if you have double doors where you wouldn't want the lock to close before the doors are back together. So to change that, you'll need to set the minimum time access grant for the strike relay in the unit properties. If it's set to 0 seconds like it is here, it relocks the door as soon as it knows the door is open. So you can set it to any other value and it's going to wait that long before it attempts to relock the door. Okay, our next troubleshooting section concerns what to do if the lock seems to be working fine, but the credentials are not causing the behavior that's expected. Basically, we know a cardholder should have access to a door, but they're denied, or they should be denied, and they're being granted access. Now, our number one weapon in finding out what's going on in this case is the access troubleshooter, which can be found in the Tools section of the Config tool. You can use the door troubleshooter and cardholder troubleshooter here for specific purposes, but to get a really good overall picture of what's happening, the best test is to use the access diagnosis. Now this basically tests anyone you want, at any door you want, at any specific time that you want. You just need to enter all that information here and hit the Go button here. Below, it's going to give you a report for each part of the system involved in checking the cardholder's access for the door that we've specified at the time that we specified. If there are any red exclamation points like we have here, there's a problem that would restrict access and a potential cause for the undesired access behavior. Now we can usually trace the problem back to one of the components of the access rules. As you might remember from the previous webinar, there are 3 W's to access rules. Who can access the door, which is basically any access point including areas and elevators. When can they access it, and where should they have access to? So if you take a look in the relationships of the access rules assigned to the door, you can see the answers to all those questions and should be able to see the problem. Now just note here that we can add cardholder groups to the access rules, so you might want to go check which groups the cardholder is a member of ahead of time. Now by default we have 2 general access rules created in Security Center, the All Open rule and the Lockdown rule. If a door is granting access when it shouldn't, see if it's been added to the All Open rule by accident. Same thing goes for the Lockdown rule if the door is constantly denying access. The last thing to check here is the synchronization. If the unit hasn't been synchronizing, it won't have the updated information to work with and may be using old cardholder lists and schedules. Speaking of synchronizing, let's have a look at what we can do if the synchronization is failing. Now before we do that, I'd just like to give you a little background on what's happening on the unit when we're doing the synchronization. Now the memory on the unit is basically divided into 2 equal parts. Let's call them the active side that's in use and a secondary side that's used for transfers. The active memory should have our most recent list of cardholders and schedules. When we do a synchronization, Security Center sends the latest cardholders, schedules, and other information to the secondary set of memory. When this transfer has been completed and the information has been verified, the secondary memory is set as the active memory, and the old active memory becomes the secondary and waits for the next set of synchronization information coming from Security Center. Now the beauty of this process is that the unit keeps working with its current set of information right up until the point where the new set is ready and the transfer doesn't cause any operation issues. Now that being said, there are a few things we can try if the synchronization is failing. The first is to log into the web page of the unit and clear any active alarms. As we've seen, keep hitting the 0 next to the door in the alarm state until it goes green and back to normal. We can also set up the system to automatically clear the door forced and door held alarms, so take a look back at the previous troubleshooting steps for the instructions on setting up the registry keys on the Security Center server. If this doesn't resolve the issue, you might want to just verify the connection to the unit as well. There's a few other things that we can check when we're having synchronization issues. You might see problems that stem from 3 areas. Might be a problem with the firmware, it could be an environmental issue, or it could be a hardware problem as well. Now sometimes we can see a timeout issue caused by the Vertex unit if we're on firmware version 2.2.7.151 and below. If you take a look at the synchronization screen, below it you might see an error below the synchronization status. So the 2 errors that may indicate this problem are synchronization failed, error code -1, and database changeover failed code -1026. Excuse me. Now we'll need to modify some of the registry keys in our the folder that we had gone to before for the other previous registry modifications. Basically in our Vertex folder that we had modified some dwords in, and we're going to just need to change some timeout values. The keys to change or to add in there, the first one is wait time, and set that to 1200. By default it's set to 300. We also have the response timeout, set that to 600, whereas the default is 150. Now our typical default for the here I am value is 90. You'll want to try 1200 if you're having this problem. And as well we've got the next key is the max forecast day count. Set that to 30, whereas the default is 365. We also have a calm timeout. Set that to 0. The default is usually 5. As I mentioned, these should all be dword values, and once you've made these changes, just go ahead and restart the Access Manager, and just note that the units will all go offline while we're restarting it. Now another problem we might see is an issue when the when the unit falls offline during the synchronization. This you may see in firmware versions 2.2.7.149 and previous versions. So the first thing you want to do is ping the unit and check the latency times to make sure they're within about 100 milliseconds, just to make sure that we're not losing any events. From there we can telnet to the unit and try to run a simple command. So for instance df-k. Now don't close the session from here, just run that command and leave that open for at least an hour, and then after that try to send a new command. So if it doesn't respond or if the session is closed, we may have an issue with the network telnet timeout value. Now once again, in that same registry location that we've been adding everything to, the vertex folder, we need to add another dword value, and that's reset telnet connection on sync, and change that to 1. By default it's usually set to 0. Now as well, concerning elevator synchronization, there is a hardware configuration limitation, and you're going to see that in firmware versions below 2.2.7.149, not including that firmware version. So you may see evidence of the problem if your vertex unit goes yellow, and if the rules that you have applied to it and the schedules are not functioning properly for the elevator. So in the synchronization status, you may see an error: the unit is controlling more than one elevator. If you don't see any errors in there, you may need to actually do a console trace to see this. So if you suspect you have this problem, just give the GTAC a call, and we can run the console trace and take a look for you. Now just note that we can't support more than one elevator per controller, so in this case what we'll need to do to resolve the issue is add a new controller or find an unused controller, one that's not controlling an elevator, and assign the second elevator to this controller. One last thing to note, with respect to the synchronization, we've made some changes in Service Pack 4 concerning how we deal with buzzers, and we're going to have a new document available soon for syncing and buzzer troubleshooting. Okay, so we're going to move on to our last section for today, on the basics of access control wiring. Now in this section we're going to take a look at a general overview. We're going to see some important hardware information such as types of wiring, inputs, outputs, and locks, and then HID units. And then we're going to move on, take a look at a few tips to actually connecting the HID units. And finally we'll have a few limitations and best practices. So what are the major components of an access control point? Really, we only need three things. We need the access point, such as the door here. We need a reader connected to a panel in order to identify credentials, and a door lock to secure the door, such as our electric strike here. With those three things, we can do the most basic access control for this door. Now, of course, we can do a lot more than that, though. We can add a request to exit, or REX. We can connect inputs and outputs that are connected to other devices, such as a sensor to monitor window opening, or a strobe light here for an output. Now, concerning the REX, I'd just like to take a second to talk about the REX and its function. Now, when a door is open, the system will check if access has been granted for that door beforehand. If it doesn't see a valid access granted event, it will generate a door forced open alarm. Now, this is where the REX comes in. It's a way of telling the system that the door is going to open, and it's okay even though we don't have an access granted from a card holder. We can program it to unlock the door as well, but the primary purpose of a REX is to allow a valid egress. So you can sort of consider it a door forced mute button. Speaking of which, the REX can come in various types of devices, such as passive infrared sensors, microwave sensors, or you can have wired switches like a push button or a crash bar. Okay, let's take a look at the physical characteristics of the wiring you'll be using. The first one here is Ethernet. A Cat5 Ethernet cable is your most typical network cable and is most commonly used to connect the controllers to the network. The range is only around 300 feet, but that can easily be extended with routers and other network devices. RS485 is our primary choice for connecting interface boards, inputs, and pretty much anything else that's wired to the controller or the interface panel. It's one or two shielded twisted pair wires with a maximum distance of 4,000 feet. Single wire is half duplex and can be considered as one line that both parties must use to communicate, so if one side is transmitting information, the other must wait until the line is free. Full duplex, or two-wire, means that there's two lines, so both sides can transmit information at the same time, like two people talking on the phone. Weakened wiring is used to connect readers to controllers or interface panels. It is non-addressable, and data only flows from the reader to the controller. This can be used for access control devices, such as standard readers, keypads, and biometric devices, and has a maximum distance of 500 feet. Now we're going to move on to take a look at inputs themselves now. Now, inputs are used to monitor state changes on things like sensors, switches, and buttons. The state change is seen as a change in the voltage. Now, we can configure inputs to be normally open or normally closed, depending on the state of the input when it's not reporting an alarm. This depends largely on the hardware being used. End-of-line resistors can be connected to the input to supervise the connection for any shorts or broken wires. When we're not supervising the input, so that means we don't have any resistors set up, we can have two states for an input: alarm and secure. The most common type of supervision uses two resistors, and it gives up to four possible input states: secure, alarm, short, and trouble or open. Now we're just going to see an example of this in the next slide coming up. Now when we're talking about the end-of-line resistors, we call them that because they're most effective around 6 inches from the input contact. The resistors we use are typically 1,000 ohm resistors, which we'll use in the next example. Now the reason we put them so close to the input contact is because it cannot detect a problem between the resistors and the input contact itself. So let's take a quick look at an example here. Now we have our meter here connected to our door contact here, and this contact is in a normally closed, is set for normally closed, and it is in a closed position at the moment. We've got our wires going through here, and just note that when it comes to the wiring, it's going to try to take the path of least resistance. So here we have our resistors set up. They're both 1,000 ohm resistors. Now at the moment everything is closed, it's normally closed and the connection is closed, so the current goes right through, and it's only hitting this one resistor, so we're seeing 1,000 on the meter here. If we actually open up the door contact, it's in an open state, we're going to see it's 2,000 on the meter because it's going through and it can no longer make a connection here. This is broken here. So it's going through the first resistor here and then the second resistor, and that's giving us a value of 2,000 since we've got both 1,000 ohm resistors here. Now we're going to close that up and take a look in the normally closed state. And let's say we get a short somewhere between the end-of-line resistors and the controller over here, which we've got the meter set up in its place. So if we have a short before that, we can tell because we're not getting through to that resistor anymore. It's just going to the short and coming back, so there's zero resistance. Now back to our normal state. Let's see what happens if we put the short between the end-of-line resistors and between the input itself. If we get a short here, then we can see it goes right through, and it still hits that same resistor that we had last time and comes back. Sorry, there we go. So it'll come right through, come back, and we're still seeing 1,000. So this is the reason why we want to keep this connection here as short as possible. Now, in a case where there is an actual problem with the wire, that's basically you won't get any reading whatsoever. So this is what we know as our trouble or our open state, because there is an opening in the wiring. Okay, so we're going to move on and take a look at the outputs at this point. Outputs are relays or electric switches that a controller or interface panel can activate, typically to cause another action to happen on another device. The most common uses we have for outputs are for unlocking door locks, which you'll see listed as strike relays in Security Center, or for activating elevator buttons. Now, of course, we can do a lot of other things with them, such as activating strobe lights, setting off alarms on the fire panel, and activating a siren. Now, there are three types of relays to consider. We have our double pole, double throw, such as down here. We have a single pole, double throw, and a single pole, single throw. Now, for the diagrams here, just note that C is our common wire. This is where the pole that we connect our common wire to. NC is the pole for a normally closed device, and NO is the pole for the normally open device. Now, we'll see a couple of examples in a minute to explain how these work, and we'll use the most common relay you'll see in access control, which is this one, the single pole double throw. Now, talking about locks, the two most common you'll see are magnetic locks and electric strikes. You may also have lever sets, such as a ring lock or a mortise lock, and vertical rod locks as well. Each one of these has its own advantages and disadvantages. So a lock can either be fail-safe or fail-secure, which is sometimes called non-fail-safe. Some locks can be configured for one or the other, but some types are fail-safe only or fail-secure only. What we're referring to here is how the lock will react when it loses power. Now, fail-safe locks constantly need power in order to stay closed. In the case of a power loss, the lock will open. Now, these are good for perimeter doors where people should be able to exit in case of a power problem or other emergency that cuts the power to the lock. A magnetic lock is a good example of a fail-safe lock, as the magnet will not be active without power. Now, fail-secure locks need to be supplied power in order to unlock the door, so if the power is cut, the door will stay closed or secure. Some, if not most, electric strikes are configured for fail-secure operation. Now, if you need a lock in a fail-safe or fail-secure configuration, you may need to order it this way. There are other types that are configurable, although changing from one to the other may take a little work. The lock manufacturers should be able to assist you with any questions concerning this for any locks that you're considering. Alright, so let's take a look at an example of both, starting with the fail-safe lock. Now, we're using a mag lock in this case, and as you can see, we have one wire connected from the power supply right to the lock, and the other one is going to the common pole on the relay. The other wire going to the mag lock is connected to the normally closed pole. So in a normal state, the circuit is complete and we're providing power to the lock. When the relay is activated and power is provided to the coil here, it's going to flip the switch here to the normally open, and that's going to cut the power to our magnetic lock, and the door will open. Now, if the power is cut here as well, if it's cut off, we're going to see that the lock will disengage as well, because the circuit will be broken at the power supply side here. Now, let's take a look at the same configuration using an electric strike, and this has been configured for fail-secure operation. Now, once again, the black wire goes from the power supply to the lock, and in this case here, we've got the common pole connected to the power supply, and the difference is the other wire coming from the lock is going to the normally open pole. So when the switch is in a resting state here, there's no power provided to the coil, we can see that there's a break in the circuit here and there's no power being provided to the lock. If the switch is activated, it's going to flip over to the normally open, and that way we will have power and it will disengage the lock. Now in the case of a break in the power supply, the circuit will remain in the open state and the lock will stay closed. Now related to the locks, I'd like to talk about the power supply wiring for a minute. Now, when we're considering the power supply, you'll need to know the capacity it needs to provide, as well as the distance to the lock and any degradation that may occur. We can generally use anywhere from 14 to 18 gauge wire for power, 14 gauge being thicker wire than 18 gauge. Now the lock coil stores energy to stay active or to unlock, and when it's released, it can cause problems on the access control panel. This noise or flyback can be suppressed or filtered using diodes or MOVs, which are metal oxide varistors. When looking at the strength of the power supply and how much current it can provide, consider all the devices that you're going to be connecting to it. Now each one of those devices has a current draw measured in amperes or amps, so just make sure that the total current draw of all your devices is less than the capacity of the power supply. At some point, you may have all the devices active at the same time, so anything below that total would cause a failure in the system somewhere. A good tip in general is to use two separate power supplies when using magnetic locks. You want to use one power supply for the locks themselves and another one for the controllers. Now taking a look at the HID units, I don't want to go into a lot of detail on this. I know we're a little short on time, and I think people have a pretty good grasp on what's supported and what's available in terms of HID hardware. But I just wanted to put up the list of the most common units that are provided by HID that are supported at the moment. The differences here are some for the controllers, which communicate with Security Center and are basically the brains of the operation, whereas others are interface boards which connect to the controller themselves. The interface boards here are the V100, V200, and V300. And if you take a look here, we've got a V2000. This is basically like a V1000 with a V100 built in, so we have support for readers. We also have various types of readers available, including ones with keypads to be able to use the card and pin functionality. Now I just want to point out a few tips on connecting HID units. If you take a look at the HID website or run a Google search, you'll find they have great sample wiring diagrams, including the wire colors and which connector they should be attached to on the unit itself. Now one of the big things you want to pay attention to is the RS-485 wiring to your interface boards from a V1000. Now a little planning goes a long way in that case. So you have your interface. If you have your interface boards correctly chained together, you won't be seeing any issues there. Now on the actual interface boards, like the V100 we have here, you need to make sure each one is identified using the dial in the middle to set the address. Just make sure you don't use the same address twice on the same bus. Now the last interface device on the chain must be terminated, and this is per bus. So you'll find the termination jumper on the bottom edge of the unit right here. All the interface panels should be set to the out position, except the last one on the bus, which is set to the in position. Okay, we're almost done here. I just want to point out a few limitations and best practices related to wiring and connections. Now, first of all, similar to what we discussed with the door monitor input, we should have the tamper input state set correctly, normally open or normally closed, even if it's not being used. When setting an output behavior to a relay, it would be a good idea to set it to a minimum of 5 seconds, otherwise the relay may not respond correctly. Now any inputs that are used for a specific purpose, such as the battery fail, AC fail, or tamper, must be used for the same purpose on all units that are connected to a controller. So if you have the bat fail on a V1000 connected to the battery sensor on your power supply, you can't use the same bat fail on a V100 interface as a button input if it's connected to that same V1000 controller. Now for using edge devices, we can only do card in and rex out. We can't use the edge controller to control two readers, so card in, card out is not a possible option. Now one last thing, when looking at the RS-485 ports that make up the buses on the V1000, the interface boards must be daisy chained, and you can't set those up in a star topology. Alright, so that's the end of the wiring section and the end of the webinar for today. We're going to leave the session active for about another 10 minutes or so in case you have any additional questions for Roger, Scott, or myself. Now, in case you need to review the webinar or know someone who'd like to watch it, we're going to have this posted on the Genetec Technical Assistance portal in the next couple of days. If you have any comments or feedback on the webinar, we'd love to hear them. When you close the webinar session, you'll be presented with a few survey questions. We would greatly appreciate it if you could just take a minute or two to drop a few comments in there. And as well, if you think of anything you'd like to ask or have any other comments, you can leave those in the Genetec Technical Assistance Center, or the GTAC Tech Talk section of the Genetec Technical Assistance portal forums. Now, we'll also have the general questions and answers from today's webinar, as well as links to the videos posted in the forum soon. And we'll also have the read-only version of the slides available in there as well. So once again, on behalf of myself and the Genetec Technical Assistance Center, I'd like to thank you very much for attending the webinar today, and we hope you all have a great day.